So this is real world data movement patterns with Azure Data Factory. This is me. All right, so for those of you who are not familiar with the ADF, or maybe you're just getting started and you want to learn a little bit more about how it fits in, this is kind of my take on it. It's primarily a data movement and integration tool. It can do some data transformation, but its sweet spot is really integrating data, moving it, and linking to other transform sources. So it's more of an ELT tool than an ETL tool, but with data flows and mapping and wrangling data flows, it can do some data transformation. And there's some tricks we can do to make it do some transforms more like SSIS. It moves data from a source to a sink, so it could move data from a variety of source systems. I think there's over 80 or 90 different connectors to different data sources. We'll walk through some of those today, into a data warehouse or into an ODS or staging layer. You can then, schedule refreshes on your Azure Analysis Services tabular models, and then obviously that data could be exposed for Power BI, which we're not going to be talking about that today. So primarily, it's about moving and integrating data. Data Factory in and of itself is fairly simple, I think. There's just a few key concepts you need to know. So the first is kind of pipelines. That's our unit of execution. Within a pipeline, we can have one or more activities. Activities can do various things. So think about like our control flows in SSIS. Within those activities, we can have data sets, which is the structure of our data set. That could be a tabular data, it could be a binary file, it could be the result of a web request, it could be a Parquet file. Those data sets are then mapped on top of linked services. Those are like our connection managers in SSIS, okay? And then we also have the ability to create what's called data flow. So in addition to being able to copy our data from source to source, we can use a data flow that behind the scenes will create an ephemeral Spark cluster and launch data flows, which we can do transformations, and it's kind of more like the data flow tab in SSIS. Then there's some other things that we need to consider. So there's the ability to use templates, either hosted in your Git repo or from Microsoft's gallery. So those are kind of predefined units of or kind of solutions, right, that do things like, for example, export data out of Oracle and dump it into a data lake. That could be a template. Or let's say set up an integration runtime to run an SSIS package and then pause it down. Those are all examples of templates that are out in the gallery for you to use. So you don't have to start from scratch if you don't want to. Triggers, so think of that as our SQL agent. That's how we're going to actually execute those pipelines. And then integration runtimes, that's where all the work actually happens. So whenever you're moving data from a source to a sink, so let's say I have an on-prem SQL server and I have a cloud-based Azure SQL server, and I want to move the data from SQL to SQL. I'm going to use an integration runtime, and in the on-prem version, I'm going to use what's called a self-hosted integration runtime. That's going to be the proxy that kind of punches through the firewall, that accesses the internal SQL server. It's going to send a query to it, and then it's going to route through that integration runtime into Azure. It'll move that data. So all the data comes through the integration runtime. Okay, so kind of drilling down a little bit, like I said, pipelines are units of work, so they're logical grouping of activities. Notice here in this diagram, you see I can have some precedence constraints. So similar to SSIS, I can have a completion, a success, completion, I can have skipped, I can have error. So I can do that kind of routing. There's a few limitations, so I can't create dynamic expressions like I can in SSIS. And I can't, one thing that's interesting is I can join multiple conditions to the same thing, but I can't, it's not easy for me to add expressions on top of those. And you can see here I have a lookup activity, which is actually nothing like the SQL, the SSIS lookup activity. This lookup activity returns a result set for further processing. It doesn't return it into kind of like a data flow, but I digress a little bit. And I can also run these in parallel too. So if I don't have any precedence constraints, they'll all three run in parallel, okay? They can be executed manually by using the debug, or I can actually trigger these by creating a trigger or doing a manual trigger. So I have different options. And then this is we'll walk through this a little bit. This is an example of a pipeline execution log, although there's no data in here. It shows you some of the information we have. So it's very similar to what you get from an SSIS execution log, okay? Activities are next. So we have a lot of different activities. The workhorse, or the main ones you're going to use, are the copy activities. So that's all about moving data from a source to a sink, and we'll dive into that a little bit. The data flow, those come in two flavors these days. There's a mapping data flow and a data wrangling data flow. We'll talk about that a little bit more later. And that's the ability to kind of transform and process data, kind of in a SSIS kind of data flow style. And then we have kind of some more kind of operational things. So I can take data from a lookup query and filter it using this filter thing to remove rows. I can iterate across the results of a lookup query or a get metadata operation to loop over it to do something, right? To do kind of a dynamic pattern. I can have if, I have until, and these aren't super up to date, so there's probably a few more in here that I don't have, but this is kind of a general flavor of these. Get metadata allows me to do something really cool, which is interrogate the source system. So for example, how many times have you guys ran a SSIS package where the source system has changed and that caused the SSIS package to fail? So the get metadata allows me to go and verify the schema of that data source and determine what are the data types of the columns, what's the order of the columns, what's the, how many are in there, how many columns am I seeing, did somebody remove a column, did somebody add a column? And then I can take that and use logic to determine, is it safe to proceed and copy my data, or do I need to fail gracefully and send an alert to somebody? Lookup activity is primarily used for grabbing metadata. I can grab metadata from a source system. It's the primary way to return a result set. The stored procedure activity only really executes the stored procedure. So it can do anything within that stored procedure, but unfortunately you can't get result sets back from a stored procedure. So it'll succeed or it'll fail, but any result sets that you return, any input output parameters, none of those things will be visible to ADF, unfortunately. So if you want to use a stored procedure that, let's say, returns some metadata, you can use a lookup query to do that, and that will actually give you the return values that you're looking for, but a stored procedure activity will not, and that's kind of an important distinction. I can wait, that's pretty self-explanatory. I can do web activities, I can call Azure functions, I can execute other pipelines, right? I can execute SSIS packages, assuming I have an SSIS integration runtime. And then I have the ability to set and append variables. So this, it's not a new functionality, but it wasn't out of the gate with SSIS, or sorry, with Azure Data Factory. One of the problems with Azure Data Factory initially was that you could pass parameters in, but you had no way to mutate that state. And so variables give you a way during execution to change the state of values. And then the validation activity allows me to, for example, wait for a file to show up or wait for a file of a certain size to show up. So I can kind of do the fundamental things that I need to do when I'm doing data movement to process files and make sure I have the full file or complete file, so I can validate that the file is where I expect it to be. I have some other kind of compute activities. So Data Lake Analytics, that's probably deprecated these days. It's still there in case anyone has used SQL jobs. A lot of that workload for big data has moved to Databricks. So you have the ability to execute notebooks from Azure Data Factory. You can pass in input parameters to those notebooks. You can determine which jars or different libraries you need at runtime. You can get result sets back from those notebooks. You can execute a jar. So if you use Java, that's a way to pass in instead of the notebook experience. And then you can execute a Python script directly from Databricks. So it's a good way to interact with Databricks. You do a lot of your processing and logic within Databricks, and then just execute notebooks and chain them together. You also have some big data processing things that are primarily based on HDInsight. So if you're not going to use Databricks, but you have an HDInsight Spark cluster, you can do that. MapReduce and Pig jobs and Hive. So those are more legacy these days, I would say. Then you also have structured streaming. You can use batch service. So that's a way to do custom code on the Azure batch framework. You can do a lot of kind of interesting things with that. It's a way to scale out large processing of large data sets. So some examples I've seen with that in the past are if you have a lot of like really big imagery files or video files and you need to process those and then distill the results somewhere, batch service can be a good way to do that. Also seen a lot of geospatial applications with that using the ArcGIS toolkit or other open open geospatial toolkits to process big sets of spatial data and distill it down and process it. And then you can also orchestrate machine learning by executing and then updating resources. So a lot of different activities, and we'll go over some more of those in the demos as well. But the copy activity is really our main workhorse, because most of what we're trying to do when we're working with ADF is we're trying to copy data, for example, from a source system into a data warehouse or into a staging layer. And this is what allows us to get the job done. It has a couple different properties, primarily the source property here. You can see here that I can specify a data set, which then has a relationship to a linked server. Here I have parameters set up for the data set itself, and you can see that I can use either a table, or I can use a query, or I can use a stored procedure, so I have a fair amount of flexibility there. For the sync, again, I'm going to a SQL database here. I've got an initial parameter of the table, and the database name is parameterized. Notice I can use a stored procedure. We'll talk a little bit more about why you might want to do that. Or I can just use the table directly as a sink. So that's a destination, in other words. I can optionally run a pre-copy script ahead of that. So if I needed to truncate table, or let's say I wanted to remove indexes, or create some structure, maybe I needed to dynamically create the tables in the database, that's where I could do the pre-copy. And I could actually call a stored procedure from within there, or I can just put the script in line. I've got a timeout here setting, and then I've got a batch size. So right now the batch size is set to 10,000. And so if I had to load 100,000 rows, it would basically run that 10 times, right? So it's gonna do it in increments of 10,000. It'll commit those 10,000 at a time in different transactions. Okay, and I can increase that. I can make it smaller. I can make it bigger, depending on the characteristics of my data set. It's a way to performance tune things. Okay. When you go through this copy data, the data is going to be serialized. Depending on what you've specified, it might get compressed or decompressed, and then there might be some column mapping going on. So it's going to move from the source to the sink, and a lot of the work is going to be done on the integration runtime. And an important thing to call out, and I believe this is still accurate, although they haven't republished this recently, is notice the different performance characteristics of moving things. So for example, moving an on-prem SQL server into Azure Data Lake Gen 2 is capped at 7 megabits per second, which isn't super fast, but again, your WAN network or your MPLS connection may cap out at that. So I've seen this cause some, not necessarily performance issues, but some slowdown with certain customers. But notice here, if I'm instead going to do it via a file, all of a sudden, my gates are way open, right? I've got 195, so I can use more of that bandwidth. And so what I can do is I can scale my integration runtime up to 4 integration runtimes. So integration runtimes will do high availability as well as high performance. So if one fails, the other ones will keep running and keep accepting requests. But by default, it'll also scale out each of my activities or pipelines to a different IR if I have more than one. I can also have only one. But one thing I could do, for example, if I had to move like a large amount of data, so I had a client that had a couple terabytes that we needed to move. And so what we did is we wrote a script to BCP the data out to files, and then we copied the files and got the throughput. So rather than waiting 3 or 4 days for the on-premise SQL server to run, it finished a lot quicker when we batched it out to multiple files and copied the files in parallel. Okay, so there's options there. Different performance characteristics for Synapse, right? Azure SQL Data Warehouse, Data Lake Gen 1. I wouldn't recommend using Gen 1 anymore. I'd go with Gen 2. So you can see there. And then this also kind of speaks to, they say DMUs here, it's actually DIUs these days. And we'll look at that setting. That affects the performance primarily for file-based sources and sinks. Okay. So it's just good to know, like if you see some slowness, it's good to know what can I do to tune that. And ADF actually has a really interesting tool that we'll take a look at that helps us do some performance tuning. So with data flows, this is an example of a mapping data flow. So here I've got a titles data set and a ratings data set. I'm going to filter them, and then I'm going to join them together, and then I'm going to dump the result out to a table. So this looks very much like a SSIS-based data flow. I can do all sorts of aggregations within here, and behind the scenes, what it's going to do is it's going to take this this data set, it's going to compile it down to Scala code, and then it's going to execute that Scala code on side of a Databricks cluster. So this was more recent in the last couple of years. It's now GA'd. It's becoming a lot more robust, and there's a lot of really cool features and things you can do with this as far as implementing different ETL patterns. Some issues that I've seen with this is some stability issues, as well as if you don't need to do that big data processing, right? So then maybe you don't want to spin that Spark cluster up behind the scenes. Maybe it's easier just to do an ELT pattern into a SQL server and use store procedures, right? So it just kind of depends on what problem you're trying to solve. The nice thing is instead of having to learn Spark SQL or PySpark, you can just implement these data flows inside of the ADF tool, and you don't have to learn those other languages, right? Which can be complex. Some people are into that kind of stuff. But anyway, it's a visual editor, no code experience. Wrangling Data Flows are kind of similar, only they're based on the Power Query functionality. So I believe these are still in public preview. The idea here is that I can take data sets, I can, as a business user that might be familiar with Power Query or something like that, I can write my transformations in that language to prep it, and I can pass that result set further down for either additional processing, or maybe I'm running it into some kind of data science or machine learning scenario, and so I need to prep the data set a little bit, and I can do that kind of within this Power Query type experience, okay? So a little bit of comparison between when you'd want to use these. So primarily mapping data flows are about transforming data, a lot more robust capabilities. Wrangling data flows are more about preparing data and ad hoc validation. This slide is actually, I believe, a little bit out of date, because at one point it only supported CSV, but now I believe it does support Parquet, and it may actually support additional fields, file formats as well. Mapping data flows supports a whole ton of stuff. In fact, they just released support for Delta Lake, which is a popular open source framework. And they also introduced support for Excel. And then as far as your code language, you're going to have a custom expression language as well as the visual experience in mapping data flows. And in Power Query M, in Wrangling Data Flows, you're going to have Power Query M as your primary language. And again, just remember, Wrangling Data Flows are in preview mode, whereas mapping data flows are generally available. And I believe they might even be available in GovCloud now as well, too. So a lot of options there. Data sets, so that really represents the shape of our data. We have two options there. We have implicit and explicit schemas. So an implicit schema allows us to basically not define a schema, and it'll try to take whatever you have, and as long as it maps to where you're trying to go to, it'll succeed, which is very unlike the model in SSIS, right? So in SSIS, if I change the casing of a column or the order or the data type, everything goes haywire and it breaks, right? So ADF is much more forgiving of that, assuming that the ordering and stuff maps what your destination is, right? So you don't need to explicitly define a schema. You can explicitly define a schema, and in that case, you're going to be bound by that. So if things change, it could potentially break downstream. And it's interesting to note here that these data sets are not only just for tables, right, in relational tables, so this could be Oracle, MySQL, Postgres, SQL Server, but files or folders, right? So Parquet files, Excel files, JSON files, binary documents, those are all things that you can work with in ADF. And link services, these are our connection strings. So fundamentally, we've got two types, a compute and a data store. So the data store is really, link services are really about moving data from A to B, right? Or copying data, those kind of things. The compute link services are more for executing something. So for example, if I wanted to call an Azure function from Data Factory, I would use a compute link service that's mapped to my Azure function to execute that Azure function, okay? So it's the same concept, it's just, does this thing contain data or does it process data is what it's here, and we'll walk through these as well. So as far as data stores, all the different Azure services are supported for the most part. Notice here that you have to use a specific connector, whether you're using Synapse or Azure SQL Database or SQL Managed Instance, right? So you have to pick the right one for it to work. Also note that there's Data Lake Gen 2 as well as a blob storage, as well as a Data Lake Gen 1 as well. So you got to pick the right one. It can work. Like, for example, if I tried to access a Data Lake Gen 2 via Gen 1, it can work. You're going to miss out on a lot of capabilities. So generally speaking, you want to use the right type of data store on top of them. Okay. I also have the ability to access on-prem type data sources. So things like MySQL, right? That's not hosted in Azure. Now that could be in an IaaS, so it could be in a VM. So it could be MySQL running in a VM, or it could be MySQL running on-premise, right? Other kind of services like Google AdWords, HBase queries, third-party software, all those kind of things are supported. Oracle, so I have a client that I just started working with the other day that we set up an Oracle connection to. What's interesting is that the integration runtime bundles the Oracle drivers as well as the Postgres drivers, so you don't need to separately install like the Oracle Instant Client, for example, or the Postgres drivers. Those are all bundled with the integration runtime, which greatly simplifies the deployment story. You can run Presto queries, SQL Server on-prem, right? And that could be in a VM, or it could be actually in a virtual server somewhere, or bare metal. SAP, Vertica, Teradata, Spark directly, Sybase. So a whole bunch of different capabilities. And then you have what I call kind of file type stores. So these are things like FTP or SFTP file systems. So that could be an SMB file share. I can also have within that, or a Google Cloud Storage S3 bucket. I could also have within that CSV files, Parquet files, JSON files, different types of files within those file systems. So I can move data to an SFTP server. I can pull data from an SFTP server. I can do a lot of different kind of file manipulations that you normally want to do in an ETL data integration process. And then I can if I have a third-party ODBC driver that I would prefer to use, I can install that on the integration runtime, and I can call that via ODBC, or I can access a REST API or an OData feed. So there's a lot of flexibility. It's really one of the strong suites of the Azure Data Factory product, is that our service it has a lot of different connectors to different data sources. So you don't need to go out and buy, in SSIS, what you would do is you would go find third-party drivers or components to kind of make these connections. In Azure Data Factory, they provide most of the stuff up front, and they're always adding to this list. So new sources. Snowflake is another connector that recently got added. So they're always adding new things. And then our NoSQL databases, MongoDB, Cassandra. You can also use Cosmos, right, from the Azure side. And a lot of software as a service. So Concur, Jira, Marketo, the different Oracle kind of cloud service offerings, Dynamics 365. So if you want to pull data out of Office 365 or Dynamics, you can do that. So just a lot of different capability, and then a lot of different third-party stuff, Salesforce, Xero's accounting package, PayPal, all those kind of things. And then if there isn't one of these that works for you, you can always, as long as that third-party service has a REST API, you can always pull data back using this REST activity. So there's ways to get stuff if it isn't exposed. Okay. And then our compute link services. So these are things like Databricks and Azure Batch and Azure Functions, where we need to just execute some compute. So data isn't going back and forth. It's basically saying, go run this notebook on Databricks, or go call this Azure function. I can get results back, but it's not meant for data transfer primarily. Okay, it's meant for processing compute. And just a high level kind of snapshot of all the stuff that's out there. It's a lot of different things. Templates, so these are coming from our gallery. So we've got a lot of different pre-built out things. This is pretty slick, especially if you're getting started and you want to see kind of how they're approaching it. I would say that most of these are good examples, but they may not necessarily completely be best practices, right? So I've seen some pretty interesting things in here in these different templates where it's actually saved me a bunch of time, because I can just go in, they're all parameterized, so I can just provide my information and I'm up and running with those. But in some cases, it may not be as robust as we wanted, or doesn't solve maybe some specific edge case that you guys are encountering. So it's good to look through here before you try to start writing your own stuff, but then I would definitely take a look at that template and walk through it and see if it actually meets your needs or not. Okay. As far as triggers, so there's three main types. We can do an event-based trigger where we can trigger ADF pipeline based on the arrival of a file in a blob store or the deletion of a file. I can do a schedule-based, so kind of wall clock-based, just like I would do in SQL Agent. And then tumbling window is mostly deprecated these days. It was more of a ADF v1 concept, but it is still supported. And the idea for that is, let's say you have data that's going to arrive every 5 minutes to a maybe like a weblog data that's going to arrive every 5 minutes to a folder. I could set up a tumbling window schedule to pull that data every 5 minutes. It's a little bit more complex, I think, of a scheduling mechanism, and it's not very good at recovering, so I don't use it very often, if at all. So integration runtimes, like I said before, this is where all of our compute activity is going to happen. If I'm in Azure, and let's say I have a database in West US2 and another database in UK South, for example, it'll figure out the right region to put those integration runtimes in, at least the Azure ones. So it'll, if they're both in a single region, it'll actually keep that data within the region. If it needs to go cross region, it'll pick one or the other depending on what it thinks the best thing is. There's three types of integration runtimes. So we have the Azure integration runtime. You get one of these created by default that you don't need to do anything with. You have an SSIS integration runtime that you can create that basically creates a on-demand SSIS VM that has SSIS installed on it. You can pre-inject dependencies into that environment. In fact, one of the really cool things the team's done recently is they've used to have to write your own scripts to install stuff from MSIs, which is a real pain in the neck. But now you can just say, oh, include this component, right? So it could be Cozy Rock, it could be S1 components, different things. Another big one that's kind of commonly used in SSIS is the Attunity components to do CDC, for example, right? So things like that can get automatically installed on the environment. The really nice thing about using running SSIS packages from ADF is the fact that you spin that SSIS environment up while the packages are running. It can leverage things like SSIS scale out and other SSIS technologies. And then when you're done, you can shut them down, and so you don't pay for it while it's not running. So you pay a little bit of a premium to run those, but it's a very robust environment. Has all the capabilities that SSIS does. So third-party components work, custom components work, script tasks work, all the connectors and things like that, as well as the SSIS catalog database and all those APIs associated with it. So if you have, custom reporting frameworks or SSIS frameworks, you can continue to use those within ADF and then gradually move the things that make sense into Azure Data Factory to start saving money. And then you can also define what's called a self-hosted integration runtime. And so what that is it's a piece of software, not unlike the Power BI Data Gateway, where you install it on a VM or on a server, and it automatically updates itself. It can be set up as a cluster, so on and so forth. And then it's going to actually run the queries for us in the environment. This is just showing some of the configuration. This screenshot's probably a little out of date, so we'll walk through it again. But one thing I do want to call out, this is relatively new. When I create an integration runtime in Azure and I want to use it for a data flow, I can actually determine what size cluster I want to use. So if I'm going to run a mapping data flow, I can specify the different types of compute. So I can do general purpose, compute optimized, or memory optimized. I can define how many cores I want, and I can go anywhere from 4 to 16 on the driver. So the driver is kind of the leader node or the boss. And then I have executors which can go 4 to 256 cores. So this thing can scale out really good. And then I can actually set a time to live. So if I have a lot of data integration that's using mapping data flows, I may set a 15-minute time to live on the cluster so that once it spins up, I'm not waiting for it to spin up as I run additional mapping data flows on it. Okay. And one thing to note when you're working with mapping data flows, if you want to debug things, it actually makes you spin up a cluster. So obviously, if you're using this cluster, it's going to cost you money. And so when you're done doing development, you're going to want to turn off your debug sessions to try to save some money. Okay. And you can specify that time to live anywhere from 0 minutes, like we have here, up to 4 hours. The self-hosted, so in this case, the self-hosted is pretty simple. It just takes 2 keys, and those keys are entered into the integration runtime software to allow it to authenticate. So all that connectivity is encrypted. What's interesting is if I'm on the actual computer, I can run this express setup and I don't even have to mess with the keys. The keys get injected into this utility, but that only works when I'm running it from the local computer because it embeds the information it needs to get the keys down securely. I can also download the MSI and I can script that out, and then I can, as part of the MSI, I can put in the keys as needed. And we'll look a little bit more at that. This is the SSIS runtime configuration. So you can see I have to set up a catalog connection, right? An admin password to talk to the SQL Server database. I can specify the performance tier of the catalog database. Here's where I can specify the nodes. So I can create one node, or I can have many nodes, right? I can specify the type. So there's D4, V2. I think they now support V3s as well. DS series. There's A's, which I probably wouldn't recommend using anymore, but you can, the idea is you can pick the right size relative to the type of work you're doing. So if you need more memory, pick a VM with larger memory. If you need more cores, pick a VM that's more weighted towards cores. I can also specify the edition, so I can use enterprise or standard. I can bring my own license and save money on this as well. So there's a hybrid mode. And this just kind of shows you the different things I can do. So here I've got my data factory. I've got a SSIS integration runtime that's running some stuff. I've got an Azure integration runtime that's moving some stuff. And I've got self-hosted integration runtimes both in an Azure VNet as well as in an on-prem environment. So this shows you the different topologies that you could use. Now, all the connectivity from the data factory into these integration runtimes is going to be encrypted and secure, and it's going to run across port 80 and 443. So it shouldn't cause any trouble. There's the ability to use a proxy server. So if your organization is using a proxy server, it's very easy to get this up and running. I haven't had many problems setting this up on-prem. As far as security, there's a couple important things to note. I've kind of called this out a bunch of times, but ADF is basically our command repository. So it's going to say, go to the integration runtime and go grab the data out of here, and the integration runtime is actually going to execute that query and move it across this data channel, which is 443, which is protected by SSL. The command channel is encrypted as well, I believe. So, but no data is flowing from the ADF. So if my data factory is in West US 2, but let's say my data sources are in East US 2 and in a colo facility, let's say in New York, for example, the data is going to go between that colo facility in New York and East US 2. It's not going to flow through this data factory. So it's important to kind of understand that. Another important concept is when you create an Azure Data Factory, so in this case, I have this ADF V2 demo factory. By default, it's going to create a managed identity, which is basically a service principal that you don't control. So it's a credential that's valid in AD that doesn't have a password associated with it. So I can't go and log into a SQL server using this identity, but ADF, if it's running, can actually present itself as its identity, and SQL Server will authenticate it and let data go in and out of that. So you can, if you need to get the service application identity ID, you can get it from here. That'll let you see it in ADF. But if you just need to assign rights to that credential, you can do so just using the normal way you would assign resources. So for example, this is what a service principal would look like. You get one of these when you create the managed identity. It's also known as an application registration. So, and it's all based on your ADF, okay? Azure Key Vault is kind of another security best practice I like to call out. So if I have, let's say I have a on-prem Windows server running SQL Server. It doesn't even have to be a Windows server, I guess, but if I'm going to use a Windows credential, like an Active Directory credential, I'm going to have a password and a username. Now, if I store that password in Key Vault, then I can use ADF to retrieve that. And so to do that, I have to create a link service to my Key Vault. that connects to the Key Vault, and then when I create a data set to that database, I use my Key Vault connection to retrieve the value of a key, and then that puts the password in there. Now, by default, ADF is going to encrypt credentials anyway, but by putting it in Key Vault, it allows you to centrally store all those secrets, right? And so, and you can put other things inside of Key Vault, so you can do certificates, you can do secrets, which are basically just strings, and keys, right? And so what's interesting about Key Vault is I could protect like a connection string or a URL or a host name if I wanted to pull that data from Key Vault, or I could just put passwords in there. So generally speaking, it's usually good enough just to protect the password itself, but some cases you might need, the host name might be sensitive for some reason, and so Azure Key Vault gives you a way to support that scenario. So just to quickly compare the two between Azure Data Factory and SSIS, there's a lot of similarities, right? So pipeline maps more or less to a package. An activity is kind of like a control flow task. A mapping data flow or a wrangling data flow is similar to a data flow in SSIS. Link services are our connection managers, right? Sources are like our sources in our data flows, and sinks are like our destinations. In a copy activity, though, I can only move data from A to B. I can't transform that data in flight, if you will. So that's kind of a quick overview of ADF. Mark, are there any questions queued up that I can help with?
There is one that's probably worth asking. In your copy data sync script, there's that pre-copy script section. So let's say you do a check to make sure that there's certain piece of data or even no data in the table. Can you raise an error in that code and cause the data factory pipeline to terminate?
Ooh, that's a really good one. So let's take a look and see. I'll show you guys what we can do here. So get out of I'll go a little bit off script, which is always dangerous, but I've got nothing to fear. So what I'll do here is I'm going to create a new pipeline. Oh, so let's talk about this because this is going to look really wonky to people. So what I've done here is I've actually used Edge, and I've created an application with it in Edge, and you can do this within Chrome as well. It removes all the browser Chrome. You can see I kind of still have some artifacts up here on the top row from plugins and extensions I use, but I like this. It gives you a little bit more screen real estate. If I've got two ways of launching ADF, so let's take a step back and look at that really quick. So I'm a really big fan of this global search and the ADF portal. So I can pretty much type whatever I want in here and get to it. So if I want to see all my data factories, for example, data factories. And so and the creation of a data factory is very simple. There's not a lot to it. It's basically just determine where you want it to live, in which resource group, in which region, and then you connect it. You can connect it up to a source control repository, which I'll talk about in a minute, using that add button. So there's not a whole lot to that. Now, if I go back and show you guys what I really wanted to show you, which was how to get to that UI, I can do author and monitor here, and that'll launch that authoring UI. In fact, if I click on it, live dangerously, now it's going to pop it out into who knows what browser, but it's going to pull this up and it's going to dump me directly into that. And notice the URL here is adf.azure.com. And if I click this little pencil icon, I'm in the authoring experience, right? So notice that. And then I have all my factory resources. So all my pipelines, data sets, and data flows and templates are all arranged in here. Notice here I have it connected to a Git branch. I can publish, which we'll talk about in a second. I can validate, I can refresh. Here's where if I click this button to turn on Dataflow debug, it's actually going to spin up that cluster for me. So let's get out of this browser and we'll use my special one since that's what I want to show you guys. So the question was, how can we do some type of an error? So I'm going to create a new pipeline here, and I'm going to go in here, and now I need to pick an activity, right? And this thing is maddening. So this is a new, for those of you who've worked with ADF before but haven't been in there recently like me, you'll notice that they now squirreled away our properties. So where I name it is now over on this right hand side. So I'm gonna call this pipe error. And there's some special naming rules you've got to comply with. But this is good enough. And let me move that over there. So I've got that. And then the rest of my stuff is still over here in the main window. So it used to be the properties were over here. So it's still going to throw me for a loop occasionally. I'm going to go ahead and do a copy activity. I'm going to go in here. Now notice there's a little red one across these. It's saying your configuration is either erroneous or it's not complete. So what I'll do here is I'll go in and I'll find one that already exists. So I think I have, let's see, what do I have? I think I have, let's look at this. I think this is right. So I'll try to preview it, see if it logs me in. That's slow. While we're waiting on that, I'll go to the sync so we can kind of answer the question. So what I'll do here is I'll move it to an ADLS. Let's see, actually, let's do a new one. So I'm gonna do a new, I'm gonna use ADLS Gen 2. Go to continue. I'll use CSV just for example, but I could use Parquet, ORC, Avro, binary, or JSON if I wanted to. I'm going to call this ds underscore ADLS v2 underscore CSV2. I think I already have one in there, so that's why it bombed out. And then I'm going to use this ADLS connection. I can put the first row as header in there, and then this is going to map out, and my container is named DLS. I have a directory hopefully called demo, and my file is going to be customers 2.csv. So that's how I can, and I can parameterize this, right? So if I click on one of these, I can parameterize it. I'm not going to bring a schema in. So I've got some options there as well. So now that actually, sorry, I've actually got to use a SQL source. So let's walk through. Let me see here. Let's go into our toolbox. So if I click on this toolbox, you can see I have all my linked services, and here's one for AdventureWorks LT. So what I can do is I can test this. Now, one thing I want to call out about this is right now what I'm doing is I'm using that managed identity. So it's going to use this ADF DP ADF identity. But I could use SQL authentication, or I could use a service principal directory. So I have some options there as far as doing that. So I've got this LS AdventureWorks LT. So let's go back to the pipeline. Okay, and let's change that source to use, we'll create a new, and then I'm going to do Azure SQL. So notice it's asking me, even though I'm creating a data set, I already have the link service existing. It's asking me what type of data set am I creating. So I'm going to create an Azure SQL database. We're going to call this ds underscore ASQL underscore cust for now. And I'm going to drop this guy down, and then that's going to hit my data set. And it'll try to bring in an existing table. So as long as this table matches what's coming from the source, it should work. I can also type in a table name there. I'm not going to import the schema, so I'm going to click none there. And I'm going to hit OK. And now, notice now my options change, right? And so the question was, finally, if let's just say I wanted to go in here and check to see if that table existed, because it's not gonna validate this until it tries to copy data into it. So what would happen is the pre-copy script runs once. So if I have 100,000 rows, it's only going to run once. So what I could do in here is I could type in, I could use raise error, right? Or I could use a throw block, and to basically say to check sys tables or information schema and say, if this table exists, great. If not, I'm going to throw an error. And when I raise that error, the component will fail. And then what I can do is, so this is probably a little bit silly, but let's say I have a webhook that encapsulates like the ability to send. So the real use case is I might have a Azure function that sits behind a webhook, which is just a URL, and I can hit this URL and say, okay, if this copy activity, if it fails, then I'll just drag that over there and call this webhook, and then it would launch my error handling process. And that it could do anything, right? It could run a PowerShell PowerShell runbook. It could send an email through a logic app. I could call a function. I could do all sorts of different things. Probably the right way to do that pattern, though, is I would use this get metadata activity, and I would link that into here, and then I would call the get metadata activity. And let's just do a real simple example of that. We got a few minutes. So let's run that. And then notice here I got a field list, so I can pass in column count, I can get the structure, or if it exists, right? And so when this get metadata activity runs, if the thing doesn't exist, it'll fail, and then I can do some activity there. Now, one thing you'll notice about this copy activity is there's no post copy script, right? So if I want to do something afterwards, I've got to drag a SQL source to it, okay? So that was a high level. It was a little bit more time than I want to spend on it, but that's okay, because I think we've got a little bit of time. So let's go through this. So some design patterns that you can do. Now, these are just basic load patterns. So sometimes you want to truncate a table and then load new data into it. Sometimes you need to do a delta or a merge load, and then sometimes you want to do an incremental load. And the difference between a merge and incremental, merge is really, I'm going to pull all the data from the source, and I'm going to see what I have in the destination, and I'm going to bring those rows in. Incremental means I can only pull the changes using either change tracking or CDC or some kind of other approach to just get the deltas and then apply that to the table. So that's the difference there. And then the bulk table transfer will just iterate over a list of tables. So let's say I have a control table that has all my tables in it. I can say, select star from that control table, and I'll iterate across those. So just a high level look at what that pattern would look like, right? So I'd have my source table, I'd have my sync table, I'd have a copy activity, I'd have my integration runtime, and I would move the data through and truncate and load. And I would use that pre-copy activity to do a truncate table. So I've parameterized the pipeline. So I've got a source reader query, that's just my select statement. I've got a pre-copy script that's truncating that table. I've got my batch size parameterized, so I'm going to do 1,000 rows. In this case, we can ignore these two because we're not using it in this pattern, but it was put there to support the later pattern. Notice here I put my source table name in there from the pipeline, so I use pipeline and then the dot parameters collection and then the source table name, and that pulls it from the parameters that were passed in. From the sync standpoint, I'm using the same approach to define the sync table name, and I'm going to use the sync pre-copy script to do that truncate, and then I'm going to parameterize the right batch size, okay? And then I'm also can put some user properties. So these can be useful. So I've got a batch ID, which uniquely identifies which ETL process I'm doing, as well as a source and a destination, and it'll populate those into the actual log, the ADF execution log. So full extract, if I don't have a reliable way to do delta detection at the source, I've got to get the data out of there. And what I'll do is I'll have my source table. I'll define a table type variable and use a stored procedure to insert the data into the sync table. And the reason why I do this is because I can actually do some transformation within that stored procedure that I can't in a standalone copy. Okay, so there is a little bit of a performance impact to this. So this wouldn't be appropriate for very, very large data tables. But for tables, on the order of like 1 million or less, it's probably going to work. It can work larger than 1 million, but it's just going to take longer. There are some patterns using global temp tables because if you're loading data into Azure SQL, it's not going to allow you to do what's called bulk load or minimal logging. And so tempdb is always minimally logged because there's no redo or undo on that. And so if you create a temporary table in that global table space, it'll load the data very fast right? It'll be much quicker than loading it straight, but I digress. So same concept here. I'm parameterizing things. So I've got my source table and my source reader query. I'm actually creating this hash function here using the hash bytes to basically concatenate all my non-key columns, and I'm going to use this to determine whether the rows change from what I have or not. So as long as the table has a primary key, I'll say I'll basically, the algorithm I'll use is say, do the primary keys match? If they don't, it's a new row. If they do match, has this hash changed? If the hash has changed, I'm going to insert the new rows. So this is a very reliable way to do that delta detection. Notice here I'm using the SHA-1, and I have to handle nulls and string conversions inside here. So if I have date columns or null values, I have to wrap them around nulls, and I'm using these pipes to create separators between the different fields. The reason I'm doing that is so that the hash is stable as it changes, and it's going to be a little bit more robust, right? And notice I'm casting it to an ncar 40, so that's going to do it very efficiently and minimize the size of that hash, and also make it a little bit more user-friendly to see. I'm going to call my stored procedure. I'm going to pass in this table type here, and I'm going to pass in the sync table name. I'm going to pass also in, the other thing I can do is I can pass parameters into the stored procedure that are from the pipeline itself. So I could pass in the batch ID, I could pass in the execution ID. I can change my write batch size here as well. This is an example of the table type. So we're just creating a type here, and we've got our values in here. And notice I'm creating a primary cluster primary key on customer ID. That's my unique value that'll help from a performance standpoint, modestly. And then my stored procedure is just takes that table type as a source. Notice I'm marking it as read only here. And then I'm doing my merge statement. So a lot of people might not like that, but that's their problem. I'm comparing the two customer IDs, and then if they're equal, I'm gonna, and the hash keys changed, then I'm gonna update. If they're not equal, then I'm gonna insert. And then obviously the problem here is this isn't gonna handle deletes, right? Very well. And then it's not going to do anything if the values match, which is actually what we want, right? We don't want to update rows when there's no change. So that's that. This is just showing you what that hash key might look like, right? And the function. So we kind of already spent some time on that. There's other functions that I wouldn't use, like MD5 with hash bytes is not recommended, nor is checksum. So neither of those two functions would be appropriate for hashing. This hash bytes SHA-1 is what I'd recommend. You will get a warning that it's a deprecated, but that's only been deprecated for encryption purposes. They recommend SHA-256, I believe. SHA-256 generates a larger key size, so I don't like to use it because it's not as efficient. Because this binary 20 or this ncar 40 is a much smaller data type, so it's going to be more efficient. In here, I've got my sync table. Notice here I've got columns that aren't in the source table, like a create date time, a batch ID, update date time. So in that stored procedure, I can populate those with whatever values I want by just changing that update and insert statement. So I've got more flexibility there. And then I'm passing my user parameters. Incremental load, in ADF, the easiest way to implement that is to use change tracking right now. So we'll go through kind of some of the change tracking approach, but the idea is that you have a change table function, you've got a current version that you can query, and then you have a control table over here on the sync side where you store the last version. And so basically you go ask SQL Server to say, give me everything between the current version and the last version I've stored, and that'll bring it over as either an insert, update, or delete. And so I have a flag in my data set that I can then apply the right logic within my stored procedure. So in that case, I can actually handle deletes without negatively impacting performance. And normally what I'd recommend is use soft deletes. So this is kind of just the watermark pattern. There's some other things I can do that aren't necessarily best practices, but that you could use for certain situations. So if you have a table that is either always going to insert based chronologically on a date or an integer ID that's always going to grow, then you can just store the last date or the last integer value of that table. But that doesn't work if, for example, you're updating the rows or things like that. You could put triggers on it, right? So there's lots of different techniques. You just got to know your data before you commit to using one of these. And again, no delete detection. So I'm a big fan of change tracking. It scales for most data. There are some really large, highly dynamic data sets that it might struggle with a bit. So basically what you do is you turn it on at the database level. You specify a retention. I'd recommend 7 days. And then you turn the auto cleanup off. So anything older than 7 days starts aging out. So as long as your ETL runs within 7 days, you'll catch those changes. Otherwise, you have to reset all the data. You turn it on at a table level. In this case, I want to know which columns were updated, so I'm turning that on. If I want to turn it off of the table, I can, at the table level, I can say disable change tracking. And then here's an example of using that change table as a function to say, okay, DBO customer CT, the primary key is customer ID, return all the changes for this. And this is going to be the initial one, so I've hard-coded all these to an insert. In this case, I'm using the change tracking operation to do insert, update, or delete. So once I have changes, I'm going to grab everything between the current version and the current sync version and the last sync version, and this query will return all those rows as well as get me my deletes with my primary keys. Okay, so pretty basic. There's articles up on SQL documentation on how to work with change tracking and any of the kind of issues like if you change schema, what do you need to do, things like that. We don't have time to get into some of those things today. I can use this query to get the current change tracking version and get the minimum valid version. So there's a little typo here. If this change tracking minimum version is less than this, then I need to go back and get all the data because it's aged out, right? That cleanup's already run. So I just need to compare those timestamps. And then this is an example of a query off of my control table. So lots of different approaches. Temporal tables can work. Triggers can work too. They're not ideal, but they can work. My bulk table pattern, very similar. I have a list in my control table of tables I want to iterate across. I'm going to loop through those. Usually what I'll do is I'll use a for each loop, and then inside that for each loop I'll have a pipeline that does the copy, and then I'll just loop through each one of those and copy the data from each of those tables into the sync table and then run. As far as logging and auditing, every ETL process should have a batch ID that you define. Here I'm passing -1 to note that it's debugging. But it's usually what you want to do is use a sequence or some other value that you have so that you can relate all these different pipelines together in a single ETL load. And then what I can do is I can save that batch ID to know who modified this row, right? So which batch ID did it and when did it happen? So I've got my modifieds as well as my created, and then I store an indicator for is deleted as well. Also have here a common audit log table. So I've got all my information about the pipeline, the source, the sync, how many rows were inserted, how many rows were updated. Those are all going to be populated from the metadata in ADF, as well as the start time, the end time. So this looks very similar to the SSIS execution log. I've added error messaging, statusing, all those things. So that's kind of a best practice. This is something you have to create. It's not done out of the box, although ADF can be configured to log some of these metrics by default to a storage account, for example. Okay, so a lot of different things that you can do to make packages dynamic and use good patterns, parameters and variables to make things dynamic, for each, lookup and metadata to validate things. Sometimes you won't be able to parameterize pipelines because it's not supported in the UI, so you can do some things directly with the JSON by editing it if you get stuck, directly using expressions. And then pay close attention to cost and pricing. So as you run these, manage the DIUs that you have configured and look at how long things are costing, and prefer patterns where you're doing a bunch of work up front and then using that work in subsequent stages, as opposed to do a little bit of work and then do the changes and then do a little bit more work and then do the changes. So you want to minimize the number of activities because you're billed at a per activity level. Okay. As far as operationalizing, so you can connect to a Git repository that can either be on GitHub or in Azure DevOps, formerly known as VSTS. You specify the information. So in this case, I've got it set up to an Azure DevOps account. I've got a repository for it. I'm going to use the master branch for my collaboration branch, and then I'm going to use I can specify the root folder. I can either leave it at the root of the repository, or I can put a folder structure underneath there. And then when I set this up, I can import the existing Data Factory resources into the repository. So when I connect, then once I have a repository created, then I can go in and it'll prompt me to either create a new branch or use an existing branch. And then I can do my work. And then as I save my work, it's going to get committed into the branch of my choice. And then if I'm working in a local developer branch, let's say I've got 10 other developers working on the project, we're each going to have our own branch. And then when I'm ready for my changes to work in, I can submit a PR. And that pull request will basically get applied to the master branch. So here I've got a PR for adding something, and I'm going to delete my local branch after I merge that PR, and then I'll create a new branch for my next work item. So it's a good way to isolate changes from impacting other developers, as opposed to working out a master and having shared branch. I can also get ARM templates. Not a perfect experience here, so I can get the entirety of the data factory as an ARM template from the UI and then redeploy that. So that's kind of a poor man's way of pushing it from dev to test to production. I have to already have a data factory created for this template to go into, and there's some limitations here, but it can work. I typically use Azure DevOps pipelines and build a little deployment process. There's some videos on that I can point you to in my resources page. And then this is just showing you that with each ARM template, I can define parameters to say, where's it going to go? I can parameterize the connection string, all sorts of different things. So this is by default. It chooses what to parameterize. There's a magic file that I don't remember off the top of my head what it's called, that controls what gets turned into parameters and what doesn't. And then you can always hand edit these files if you want, but it's a bit of a mess. There's no support for PowerShell to import or export the ARM templates. So this was a connect item that I entered, I guess, wow, 2 years ago. Crazy. So vote that up if you're interested. This is just kind of walking through that DevOps CI/CD process. There's 2 really good videos on this. One was done by the Azure Data Factory team, and that was a couple months ago, I believe, that they did this video. So that's up on YouTube. And then Camille actually has a video as well that you can search for on setting up Azure Data Factory for continuous integration. It's a really good video. So it walks through this whole process, setting up the pipeline, testing it, and walking through the deploy soup to nuts. So it's a pretty big topic. You can configure logging. So lots of different things here to do with regards to logging. I can log things to log analytics or an event hub or a storage account. I can choose the retention. How long does I want those metrics to be there? And then I can do activity runs, which is just logging at an activity level versus a pipeline level versus a trigger level. And then I can store all the metrics. So it stores a bunch of performance metrics as well. Just this is the example of what that data looks like. So the types of information you're going to get, right? A little data dictionary over what's in the trigger run, pipeline run example, data dictionary, activity run. So there's a lot of metadata in here, including the output. So how fast did the data transform go? Any errors are all going to be logged in here as well. So it's pretty robust logging, error logging information. And then I can set metrics, and I can use Azure Monitor to trigger on failure or success. As well as I can get performance diagnostics from my integration runtimes as well. So here you can see I have a couple different integration runtimes. You can see how much memory is currently available, what the CPU utilization is, how many jobs are running, as well as what's the limit on each of these. Here you can see I have a 3-node configuration. So I can pull a lot of different information from that. And then this graphic's a little skewed out, but basically there's a log analytics solution called Azure Data Factory Analytics that does some very basic dashboards that works off of that performance data. And then of course I can configure alerts either through Azure Monitor or directly within the ADF environment itself. Okay, so at a high level, we're a little bit over, but this is kind of where we're at. For session resources, if you go to this link, bit.ly/data factory resources, it'll link you to my my GitHub repository that has all the links and all the resources for this session. Another good resource is the documents for Azure Data Factory, so they can be found here. You can just Google that. I always Google Azure Data Factory documentation as well. If you want a feature or a connector, you can go to their user voice page and submit that and vote for existing features. And then they're getting a lot better about blogging about different updates, like when they change UIs and add new features. So this is the blog where they publish all that stuff too. So with that, Mark, I'll turn it back over to you, see if there's kind of any questions that we can cover.
Perfect. Thank you very much for that. That was excellent. Right, so let's move on to the first question. Okay, so given the programmatic limitations in ADF, I'm sure there are some, how likely is it that I'll find myself writing SSIS packages for brand new development for my ADF pipelines?
So it's an interesting question. I think what they're referring to is the fact that you don't have like a script task, right? And so in SSIS, I could use script task if I got stuck on something. I could either use a script activity if I needed to do something, external to the pipeline, or if I need to process the data internal to the pipeline, I could use a script task. Now, what I'll say is that if the data is in any kind of structure that ADF can work with, if I can get it into a SQL database or into a data lake as a file, then I have all sorts of options, whether that's using Databricks to process it, or using a stored procedure to process it. So I've got those options, right? So I try to find, unless I already have that SSIS package written, I try to find a way to fit that processing into my data pipeline and use, I don't want to say a more modern technology, because I think SSIS still has a place for certain things. But I'll definitely try a different way. I'll try to approach it using an ADF type of a pattern or a big data pattern, as opposed to using kind of more of a legacy like SSIS approach, I guess. So I've not seen, when we've hit roadblocks with ADF, we've usually used a Databricks notebook, or an Azure function could be an option, or a stored procedure, and usually those have worked. I can't think of any environment where I've had to migrate, for example, an existing SSIS package that couldn't be refactored into an ADF kind of native solution.
Perfect. Just talking about migrating SSIS packages then, would the first steps of doing so first be creating your ADF pipeline with the package running inside, and then slowly building that out? Or would you just architect your pipeline completely from scratch and design it with all the ADF components? How would you approach a migration?
Yeah, no, it's a really good question, actually. So, and there could be a whole session on this, but the first thing I would do is I would assess the existing SSIS packages, and I would try to figure out what they're doing. If I had a lot of stuff that was basically just a source and destination and no transformation in between, I would actually re-implement that as an ADF pipeline and make it dynamic, because a lot of times, if you're moving, for example, if I'm moving 100 tables out of Oracle into SQL Server, I'm going to probably have 100 different packages in SSIS. But in ADF, that can all turn into one pipeline. Now, if I have a lot of complex logic, like let's say I'm using a third-party component and I'm doing some processing and I've got a script task, then I might just move that package using the SSIS runtime and integrate that into kind of an overall orchestration. So things like master packages, those are good to be native ADF pipelines, as long as there's not a lot of complex logic, and then cherry pick the pieces of SSIS packages that you need to leave in SSIS. For sometimes it's just a matter of you don't have enough time to migrate it all, or sometimes it's too much of a headache and you don't want to do the work. So, but I would always analyze those SSIS packages and look for opportunities to kind of consolidate the number of SSIS packages that you're dealing with. I believe, I want to say, now I've not used it myself, but I believe Verigence actually, who makes BIML, I think they wrote a little conversion utility to move SSIS into ADF. So you might want to look at that. And then there's certainly, I know Andrew has his open source ADF framework that's out there that you can basically just download that, configure it, and it'll start moving data for you. And then you can build on top of that and put your own. So ADF is really good at moving data from A to B, but any of the transformation, the cleansing and enrichment, you're gonna have to write that logic yourself, right? There aren't a lot of great generic frameworks for doing that. So if your SSIS package is doing a lot of that type of work, then maybe that logic should stay in SSIS. But if it's just moving data from A to B, I'll migrate it to ADF.
Perfect.
Mhm.
So you talked about, or you briefly touched upon the publish button in ADF. Could you just explain exactly what's happening by pressing the publish button?
So that's a great question. I apologize. I probably should have given that a little bit more time. So in ADF, when I'm not connected to a source control repository, when I'm working in that environment, I'm working in kind of like a temp space, if you will. Now, if I want to save that and actually run it, I have to actually publish it. Now, if I've built a configuration, like remember when I was building that copy activity and the little red ones go on there, so it's not complete and therefore it won't publish, so it won't pass validation. If it won't pass validation, I can't publish it. And then when I close my browser, that work's gone. Now, if I'm connected to a source control repository, I can save it without it needing to validate, and then it gets saved, so I can save incomplete work. So I definitely recommend always connecting to a source control repository. Now, what's interesting is when I trigger something, so let's say I trigger something to run at midnight, it's always going to run the published version. It's not going to run the local version or even the latest version that I checked in. So if I'm working in a team environment where I have my source control, once I check it in, that doesn't publish it, right? So to publish it, I've got to check it into my branch and then move it into that collaboration branch by doing a pull request. That's going to put it in the collaboration branch, and then once it's in the collaboration branch, I can actually publish it and deploy it. So it's almost like you have three workspaces. You have the publish slot, you have the collaboration branch, and then you have your local branch, right? Three workspaces. So that's definitely something I should have probably covered a little bit more in depth, but I was kind of rushing through it. So hopefully that clears it up. But the best practice is you connect it to version control and don't edit code within that collaboration branch. So if you're going to change code, get it into your local branch, make the change, and then merge it in. Don't manually make edits to the collaboration branch, because what will happen is if I change something, let's say I'm working on a pipeline and Mark's working on a pipeline, and I finish mine, I move into the collaboration branch and it doesn't pass the test. So I go in and I fix it in the collaboration branch real quick. Then when Mark goes to commit, there's going to be a conflict, and he's going to be stuck resolving that, and he's probably going to curse me out the next morning. So always publish and pull requests. Don't ever commit to master or the main branch.
Excellent. It's probably worth also saying that you can enforce people not being able to do that by using your branch policies and prevent people, so you can force people to do a pull request to merge in.
It
Right.
sounds like you've been bitten by that.
I've been bitten by a lot with ADF.
Yeah.
So, all right. So earlier in the presentation, you talked about the templates which will in the gallery, which will make our life easier. Is it possible to create your own templates and also maybe even monetize them?
So there's no monetization capability yet, and unfortunately, you have no way to create your template and push it to the gallery. What you can do is, if Mark and I are working on the same project and we share a GitHub repo, we can create templates and publish them to that GitHub repo, and then anyone with access to that GitHub repo can pull down those templates, but they won't show up in the Microsoft gallery, which is really unfortunate. I don't really know what's going on with that. I kind of expected there to be a little bit more development on the templates, but I haven't seen any changes with that. So I think, I suspect Microsoft did it kind of as an experiment, and I haven't even seen like new templates show up. So who knows like when they might add additional capabilities. It would be really nice, in my opinion, to be able to get stuff vetted by Microsoft and publish it there. Now the flip side of that is, if I go create all these things under the all these items under the covers, triggers, pipelines, data sets, link services, they're all JSON files. So if I just dump the JSON into a GitHub, anybody can grab that JSON and paste it into there's an editor where I can paste JSON in and it'll pull up, right? And I might need to make some minor tweaks to it, but kind of a poor man's way of doing that. And then there's always the ability to export the ARM template. Unfortunately, it's all or nothing, so you can't cherry pick the exact changes, which would be really nice to do hot fixes. If I could just say, just export ARM template and then be able to say, okay, I want to get this link service and this pipeline only, dump it out for me, right? But you can't do that.
Yeah. Fantastic. Right, so this is a problem I've run into, and it's about ADF support for VNets. Is it possible that ADF either does or will support VNet so that you could have a full end-to-end data pipeline solution within the confines of a single VNet?
So I think the answer to this is no. My hesitation is they recently released Private Link, and I don't think ADF is on that list of private
Right.
links.
Okay.
And so obviously there's VNets, there's support for accessing resources in VNets, but your ADF factory is still publicly exposed via that endpoint, that adf.azure.com. And Mark, I'm actually curious on your take on this, because to me that's not a huge risk, but I can understand why some companies might not want that exposure, right?
Yeah, I mean, I can tell you how it came up. So I took over a project where the end client, for some reason, they wanted the full VNet encapsulation of the entire solution, and we'd basically promised them that the ADF, well, it would be, and that obviously ADF would have to do that, and the only way around it that we found was to have a virtual machine and then just run the integration runtime inside it. So then you could have the virtual machine within the VNet. So that was the only sort of workaround that we could find.
So they were worried about was that to replace an Azure integration runtime then?
They just didn't want any data to go outside the confines of the VNet.
Ah, gotcha. Okay, yep, that makes sense.
Which, I mean, you could argue it was a bit daft because there was an event hub which was actually outside pushing the data in, but they weren't really looking at that.
Yeah.
Anyway, we move on. So when would I use an ADF mapping data flow over a standard ADF pipeline copy data task?
It's a great question. So here's the this will actually be a really good blog post, I think, because the guidance has probably changed a bit over time as the mapping data flows have become more robust. But my opinion, which is going to be way different than Microsoft would tell you to probably always use a mapping data flow. If you just need to move data from source to sink, I need to move a file to blob storage. Or I need to copy this table into a database, and I don't need to do a lot of transformation or just very minimal transformation, use a copy activity. And then if the data volume doesn't warrant it, then use the stored procedure approach. If the data volume does warrant it, use kind of a stage approach where you copy it to a staging table and then run a stored procedure on top of it to transform, cleanse, and enrich, okay? If I have a large data set, so let's just say arbitrarily over maybe 10 million rows or maybe 100 million rows, around that size of data. So talking easily over 2, 3, 4, 500 megs of data or gigabytes of data or terabytes of data, and I need to process that efficiently. Mapping data flows is going to use Spark, so it's going to scale out and it's going to be much more efficient. And if I need to do transformations. So here's a great example of when I'd want to use a mapping data flow. Let's say I'm getting telecom call detail record data, and I need to aggregate that up to a daily or monthly level. So let's say I run it once at the end of the month and I aggregate all the call detail level per phone number and maybe by some other groupings. If I'm going to do those types of big aggregations, I'm going to want to do those in mapping data flows because it's going to process that larger data set much better. If on the flip side, I've got 10,000 rows and I just need to update, let's say it's some master data or something like that, then I'm just going to use a copy activity, right? So you can mix and match both of them within a single solution, even within a single pipeline, right? So let's say I do my aggregation. Let's say I aggregate that CDR data to a monthly level, and now I have, let's say, 100,000 rows, and it's stored in blob storage. So a mapping data flow can only grab data from a sink and store it down at the end of the day from a source to a sink, right? So it can transform it in the way, and it can reshape it, and you can join it with other data sets, so on and so forth. But at the end of the day, the output has to go somewhere, and it could be a database or it could be blob storage. But once I get that data summarized or aggregated and down into my blob storage, I might come along and use a copy activity to load it into the database, right? I wouldn't have to, but I could do that if there was some reason to do it, right? So in my mind, mapping data flows, you have to have a scalability problem. So you have a lot of data volume, or you need high velocity, so some of the big Vs, or you need a lot of complex transformation logic, right? And in my opinion, and this is my bias because I'm kind of more comfortable with PySpark and Spark's SQL. If I'm going to do any kind of Spark processing, I'm probably going to do a notebook first, because I can just control that Python code and I know exactly what's going on under the covers. I don't get the rich level of integration that you get with the mapping data flows, and I have to actually figure out all the code and stuff. But in my mind, it's pretty easy to write that Spark code and instrument it and do things like that. So mapping data flows is for people who don't necessarily want to learn Spark, but need to leverage the big data capabilities.
Okay, perfect. Thank you for that. Right, given the time, if you don't mind, we'll run through these. We've got 4 more questions.
Yep.
If we can run through these ones quickly then to keep you
Sure.
on target. So first one, in your integration runtime earlier on, there was a standard edition, or you said there was enterprise. What happens if you choose one over the other? Do you lose functionality?
So the big thing that you lose, if you think about what's included in SSIS Enterprise versus Standard, is like fuzzy lookup, the CDC components and things like that. So obviously, if you pick Standard, but the pipelines the packages that you run are only using standard features, it's not going to be a problem. But if as soon as you try to use enterprise features in a standard environment, it's just not going to work.
Right. Okay. Thanks for that.
Mm-hmm.
Next question, MS Dynamics 365 as sync in ADF. Do you have any experience in this respect? Are there any caveats?
So I don't, unfortunately. I've used it as a source before, and it seems to have worked. The caveat is that if you think about data sources and connectors, they're not. Some data sources can only be. Some data connectors can only be sources, and some can only be sinks. It's more likely that a data source only supports a source versus it supports both, right? So I don't think there's any write-only, sync-only data connectors, but
Right.
you might. So just because Presto is a great example, I can run a Presto query, but I can't write the data back to Presto because Presto, it doesn't support a data store, right? It's a query language fundamentally, so there's no way to make that work. And so just be very leery that when you're looking at some of those third-party components, make sure that it has both the ability to read and write the data if you need to write the data back. Now, there's other ways to do that. Azure Functions would be a good way to do that, right? So that's kind of the Swiss Army knife. If ADF doesn't support the ability to read back to or write back to that data source, you could always write Azure Function and write the custom code. So there's options around that, but unfortunately, I don't have experience with those specific source or sinks.
Okay, brilliant. Next question, if my sink is Azure SQL not managed instance, will the stored procedure with merge statement still work in ADF? According to my Googling, merge is supported in Azure SQL database, so I don't know if you'd concur with that statement or not.
Yeah. So merge will work in managed instance. Merge will work in Azure SQL DB. Merge will not currently work in Synapse or SQL DW. However, there is a public preview for the merge statement that you have to sign up for, that you can get merge statement support in Synapse. So all flavors, and obviously SQL Server, all flavors for merge could potentially be supported. One of them, you have to join a publicly announced but opt-in preview.
Fantastic. So final question is about your slides and any example code. Can people get hold of any of those things at all?
So that link I sent up, let's see, do I still?
Oh, right. Okay. So it was the one at the end of the video, wasn't it?
Yeah, it should
Yeah, perfect.
be that bit.ly/data factory resources. Everything should be up there. Definitely reach out if you're looking for something. I don't publish the PowerPoint, but I do have a PDF that I can send you of the deck. And then there's also, if because I rushed through some of the demos, there's other previous recordings of this session where I've got kind of more demo action going on. So if there's things that you guys want to see specifically with like the change tracking pattern or some of these, there's multiple recordings up of that. And they should all be in this link. If they're not, I'll get them there if you send me an email.
Brilliant. Okay, that concludes today's webinar. Thank you so much, Jason, for giving us your session. Really enjoyed it.
Yeah, thank you. Appreciate it.